It's again, right, with electric exam number 2 is gonna be Wednesday, November 15th. All right, so the heart's the center of our cardiovascular system. So what the heart does, right, it's gonna pump blood, okay, through blood vessels. So we're gonna take oxygen and nutrients to all the cells of the body, and we're gonna get rid of carbon dioxide away from the cells of the body, okay? So the heart's a pump. It's gonna pump 100,000 times a day, or 35 million beats per year. Okay, about 5 liters of blood go through our body each minute. Okay, it's actually 5.2 liters, but round it down. Okay, the study of the heart and the diseases that can affect the heart and the treatment of those diseases is called cardiology. It's called cardiology. Okay. Okay, so this is important here. So the heart's located in the mediastinum. The mediastinum is just an area. Okay, the mediastinum is just an area. It's going to be, that area is in between the lungs, back of the sternum, and in front of the vertebral column. So if you're going into radiography, they'll ask you, they'll say mediastinal x-rays, and you're checking the size of the heart. Okay? Right? So the heart's, 2/3 of the heart's on the left side of the thoracic cavity. Okay, so we're going to see that our right lung has 3 lobes, our left lung only has 2 lobes. But it's got like this little notch, it's called the cardiac notch. That's where the heart's going to sit. Okay, that's where the heart's going to sit. Okay. Now, some people, the heart's flipped. Okay, everything's anatomically correct. It's just flipped the other way. We call that dextrocardia. You never even know you had that unless when the doctor checks you and they auscultate the heart to listen to the heart. They can't hear it, so they go on the other side. Okay. So the heart weighs about 250 grams in females, about 300 grams in males. See, look, ladies, men have big hearts. Okay. So CPR is cardiopulmonary resuscitation. So this is when the heart stops beating. Okay. And so what you're doing is you're artificially pumping the heart. So what you're trying to do is get oxygenated blood to the brain. After 3 minutes without oxygen, you get irreversible brain damage. Those cells start to die. Okay, so I used to teach CPR for the Red Cross. I taught standard first aid for the Red Cross. And people would ask, there's a lot of different answers we did it years ago, but people ask, well, what if I do CPR wrong? I'm like, the guy's dead. You know, heart stopped. Okay, you're just trying to keep oxygen there until we get the heart going again. So there's really no bad way, kind of doing it. Okay. People are afraid of putting their mouth on somebody else's, so you can get the mouthpiece, the resuscitator there. I have one in my truck, a whole jump kit in my truck, but again, you don't have to do it. There's enough oxygen in their body, so just do it hard and fast. Okay, it'll help rise. Okay, so they have enough oxygen in their body, it could be going to the brain. Okay, and so this is right here's the mediastinum. So here's the 2 ribs. Okay, here's the heart. That's the sternum. That's the vertebral column. Okay, so the location of the heart is the mediastinum. Okay, if you look at here's an anterior view, right? You got on the right side you got 3 lobes, upper, middle, and lower lobe of the lung. On the left side you have an upper and lower lobe. We got this cardiac notch here. Okay, and here's the diaphragm. Okay. All right. So what surrounds or encloses the heart is the pericardium. So if my right hand's the heart, and I put my left hand over it. Okay. My left hand's representing the pericardium. The outside part's going to be the fibrous pericardium. It's dense, irregular connective tissue. And underneath, they call it the serous pericardium. Okay, well, it gets a little strange here. They also call the serous portion the parietal layer, and they have a space, and the visceral layer is actually the heart. So we don't talk about that. You just know that the pericardium surrounds or encloses the heart. The top part, right, is the fibrous part, dense, irregular connective tissue. Okay, and then underneath that is the serous portion. Then there's a space, pericardial cavity. It's filled with pericardial fluid. So every time the heart beats, there's no friction. There's no friction. Okay, so we're going to go over the layers next. So just know the pericardium goes around the heart, then know the layers. Okay, then know the layers. Okay. Sometimes we can inflame the pericardium. It's called pericarditis. And what will happen is it can either be due to some sort of infection or trauma. Okay, you get hit in the chest. It used to happen with the old cars, no seatbelts, metal steering wheel, right? You get front impact type collision and you hit that. Okay, it can bruise the heart. Okay, or, right, you get shot in the vest, right? Cops got a bulletproof vest on. The projectile doesn't go in, okay, but they're still getting a wallop, okay? So what happens is you could get bleeding inside the pericardial cavity. When it does that, it puts pressure on the heart, so it doesn't beat properly. So we call that cardiac tamponade. Cardiac tamponade. Okay, so again, very dangerous. Right? So know the layers of the heart. These are the layers right here. Okay. So the epicardium, epi means above, right? It's above the heart, the layer outside the heart. Okay. When we do dissection, we'll actually peel that off. Okay. It's a thin layer. It's very, very fibrous. Okay. It's fibrous connective tissue. Then the thick layer right in the middle is the myocardium. That's the actual muscle portion. That's what actually pumps the heart. So it actually pumps it. And the endocardium is the lining. So it's made up of epithelial tissue. When epithelial tissue is lining, right, we call it endothelial tissue. Okay? So again, you can get infection of the heart muscles called myocarditis. Okay? And again, it can happen with rheumatic fever. Okay? Or you can get endocarditis. Again, this could be due to heart valves. Okay, like a bacterial infection. Okay? Streptococcus pyogenes can cause that too. Okay? All right, so right here, right, the fibrous layer here is the pericardium. Okay, that's the fibrous layer. Then this purple here is the space that's filled with pericardial fluid. Okay? And then all this right here, this little white layer here, that's the epicardium. Okay? This all in here, right, is the muscle, that's the myocardium, right? Very, very red, right? A lot of myoglobin, a lot of hemoglobin, right? You don't want your heart to fatigue, right? And then this, the lining is the endocardium. These little folds are trabeculate coronae, so when blood gets in there, it'll open up. Okay, those will open up a little bit, okay? All right, and a pericardial cavity surrounds the heart. Okay, so know the chambers of the heart, very important. So we got two upper chambers that they're called the atria. So we have a right atrium and a left atrium, okay? The atria are separated by an interatrial septum. Okay, that's important also. Okay. Now each atrium have like a little storage bag on them. Okay, a little storage bag. So when we're doing some exercising, okay, right, we got to get oxygenated blood to the legs. Got to get it to the arms. Okay, so the more blood going into the heart, the more oxygenated blood is going to leave the heart. Okay. So as the blood's coming in, we need more blood recirculating, right? So so these auricles will open up. Okay, they make they're going to make the atria larger. Okay, so more blood can get in. Okay, so these are just little storage sacs. So again, the interatrial septum, right, separates the two. Separates the two. Okay, we got two lower chambers. They're called ventricles. You have a right ventricle and you have a left ventricle. Okay, the interventricular sulcus separates the two. I mean, the interventricular septum separates the two. Okay, interventricular septum. Okay, the coronary sulcus, okay, is going to separate the atria from the ventricles. Okay, going to separate the atria from the ventricles. All right. So know that's important. Okay, but don't get confused because there's a coronary sinus we also have. The coronary sinus, okay, that's a big vein, okay, in the heart. Okay, we'll get to that later. Okay. So we have two atria, right and left atrium, two ventricles. Okay, interatrial septum separates the atria, interventricular septum separates the ventricles. Coronary sulcus separates the top from the bottom. Okay, right? Okay, so in books, okay, they always depict the right side of the heart as being blue. Okay, that means that it's deoxygenated blood or blood filled with carbon dioxide. Okay, all right. The right side, the left side of the heart's always depicted in being red. Okay, that's showing that that's blood that has a lot of oxygen in it. Okay, it's oxygenated blood. Blood's really not blue. Okay, they just depict it like that. Okay. When we look at the lymphatic system, they depict that as being green. It's really not green. It's actually clear. It's mostly fat. Okay, it's mostly fat. So when you're studying the heart, right, you're gonna look at this page here. Okay, with, and you gotta skip down with that here, the schematic here. Okay, because this shows the flow of blood. If you know the flow of blood through the heart, okay, you do really, really well. On the test, you should know the anatomy. Okay, so, let's see, do I have, I don't think I have a blue marker, do I? I mean, it doesn't work though. I need a blue marker. Yeah, that doesn't work. we'll do black. Okay, so. Actually, let me get a blue marker. I'll be right back. They're right over here. It'll be easier to talk amongst yourselves. Time you're in charge. All right, right back. You're ready. Noise you hear putting a roof on. Putting a roof on this wing. Okay. Okay, so if the blood's coming from the left side of the heart, okay, that's gonna be very red. Why? Because there's oxygen. Okay. So then from the heart, right, that blood's gonna go into arteries, okay, into almost microscopic arteries called arterioles, okay. And then they're going to go into the capillaries. We're going to look at the capillaries being green. Okay. Now from the capillaries, right, the oxygen is going to go into the cells. It's going to go into the cells. Okay. As that's happening, all the carbon dioxide is going to leave the cells, okay, and go into the capillaries. Then from the capillaries, they're going to go into almost microscopic veins called venules. If I can spell it right. Okay, into veins. Okay, and then they're going to go into the right side of the heart. And this here is all the carbon dioxide. Okay, so now we gotta get rid of that carbon dioxide, right? So we're gonna pump that for the right side of the heart. Okay, it's gonna go to the lungs. Okay, so when you exhale, okay, all the CO2 leaves the lungs, right? Goes out into the atmosphere, okay? The next deep breath, okay, all the oxygen is gonna go into the lungs. Okay, and then from there, okay, it's gonna go back to the right side of the heart. Okay, just keep in mind, right? Arteries always go away from the heart. Veins always go towards the heart. Okay, so they always go towards the heart. So 99% of the time, 99% of the time, arteries will be oxygenated. Okay, 99% of the time, veins will be deoxygenated. The only difference is the pulmonaries, and we'll do that in a second. You see why. Okay, so I always like to start here. I don't care about the numbers, but right here. So we're getting the exchange here. So now all the oxygenated blood is going to go into arteries, arterioles, and capillaries. So the capillaries, they're very, very small. They're going to weave in between the cells to make up the tissues, right? So then, right, they're going to all the oxygen is going to diffuse out of the blood into the cells. At the same time, all the CO2 in the cells is going to diffuse out of the cells into the blood. Right? Then you have venules, veins. Okay, now all the deoxygenated blood, all the blood filled with CO2 in the top half of the body is going to eventually wind up in this big vein here called the superior vena cava. All the deoxygenated blood, all the blood filled with CO2, right, is going from the lower half of the body is eventually going to wind up in the inferior vena cava, another really big vein. Okay, now remember, the heart's living tissue, right? We got to oxygenate it and we got to get rid of CO2. Right? CO2 is the most abundant intracellular waste product in animal cells. Okay, but they're very, very toxic. Okay, put us in an acidic state. Okay, so all the deoxygenated blood in the heart tissue is gonna wind up in the coronary sinus, okay? These three big veins are gonna drain into the right atrium, okay? Then it's gonna flow through a valve. Valves prevent the backflow of blood. We'll go over those in a second, okay? From the right atrium, it's gonna go through the tricuspid valve into the right ventricle. Then it's gonna get pumped for the pulmonary semilunar valve, okay? The pulmonary aortic valves are called semilunar valves, just the way they look. So I call them, I call it by the first name and the last name, okay, just so you know. So it goes through the pulmonary semilunar valve into the pulmonary trunk. It's about 1 inch long in humans, okay? Then it's branches to a right and a left pulmonary artery. Arteries are going away from the heart. Okay, in this case, it's deoxygenated, okay? Then it goes to the lungs. Okay, so all the CO2 in the blood is gonna diffuse into the lungs, and you're gonna exhale it out. Wait. Next deep breath, oxygen goes in, all that oxygen diffuses out of the lungs into the blood. The right and left pulmonary veins, okay, pump that oxygenated blood to the left atrium of the heart, through the bicuspid or mitral valve, they have two names for that, okay, into the left ventricle, goes through the aortic semilunar valve, into the aorta, and then all the arteries branch off that. So all the arteries branch off that, arterioles, and then capillaries again, okay? So once the blood leaves the left side of the heart, it goes into arteries. All those arteries are oxygenated, okay? Those arteries are oxygenated, okay, because they're going away from the heart. So arteries are oxygenated. The only time it's different is in the pulmonaries. So pulmonaries are going to the lungs, okay? So pulmonary arteries go away from the heart to the lungs. Pulmonary veins go towards the heart, okay, from the lungs, okay? That's the only time it's different. Let's just go back here, okay? Okay, so here, right, we'll start the whole thing over. So from the capillaries to the venules, right, to the veins, and then eventually all the deoxygenated blood from the top half of the body is gonna wind up in the superior vena cava. All the blood from the lower part of the body is gonna wind up in the inferior vena cava. And all the blood from the heart itself, okay, is gonna go into the coronary sinus, into the right atrium. From the right atrium, it goes to the tricuspid valve, okay? The valves open and the pressure changes in the heart. So all the blood goes into the two atria, right? The valves open, okay, and it contracts, then they shut, okay? So all the deoxygenated blood goes from the right atrium through the tricuspid valve into the right ventricle. It gets pumped through the pulmonary semilunar valve into the pulmonary trunk, and it goes to the right and left pulmonary arteries. So it's gonna take that deoxygenated blood and bring it to the lungs. When that blood gets reoxygenated, right, we're gonna have the right and left pulmonary veins bring the oxygenated blood to the left atrium. Goes to the bicuspid or mitral valve, okay, into the left ventricle. It gets pumped through the aortic semilunar valve into the aorta, and it's gonna branch to all the other parts of the body. Okay, so, for example, the first organ to get oxygenated blood from the heart pumping is the heart. You can't see it here, but you got a right and left coronary arteries. They bring oxygenated blood to the heart tissue. Okay, all right. Then you got the arch of the aorta here. Okay, so right here, okay, you're gonna have your brachiocephalic trunk. Brachial means arm, cephalic means head. So this will branch off into the common carotid, okay, going up to the brain, and then at the subclavian, and it's going to go to the brachial and so on. Okay, on the left side, you're going to have a left common carotid and left subclavian. Okay, because of the pumping power of the heart, animals that stand on 2 feet, you can't have two. It wouldn't be able to sustain that. Cats, dogs, they have 2 brachiocephalics. Okay, they have 2 brachiocephalics. We only have 1. Okay, so that's the arch of the aorta. Then you got the descending aorta. So coming off there, you'll have your bronchioles, you'll have your splenics, you'll have your hepatic, you'll have your gastric, you'll have your mesenterics. Okay, so all the blood vessels are going to branch off that. Okay, if you notice the walls, right, of the heart here, the ventricles, look at the muscles here. So, look at the, how thin the muscle structure is in the right ventricle than it does in the left ventricle. That's because the right ventricle only has to pump to the lungs, either side of the heart, right? Whereas the left ventricle's got to pump oxygenated blood up to the brain. It's got to pump it to the toes. It's got to pump it to the fingers. So the pumping power is a lot greater. Okay? All right. So let's go over valves. So valves are going to prevent the backflow of blood. Okay? They're made up of dense, irregular connective tissue. Okay? And they're going to open and close in in response to pressure changes. So now blood goes into both ventricles at the same time. Right deoxygenated, left oxygenated. Goes at the same time, okay? And it's gonna stretch, you're gonna depolarize those cells, and you're gonna get contraction. So then all the blood's gonna leave the atria and go right into the ventricles, and then the valve shut. Lub, that's that lub sound, okay, that you hear. Okay? So when you listen to the heart, you hear lub, dub, lub, dub. That's your valve slamming shut, okay? That's your valve slamming shut, okay? So these are important too. So we have the two atrioventricular valves. They're going to be in between the atria and the ventricles. So we call them AV valves for short. Okay, so the two atrioventricular valves. On the left-hand side is the tricuspid valve. On the left-hand side is the bicuspid valve. They also call the mitral valve because it looks like a bishop's mitre hat. Okay, that's where you get that from. Okay, all right. The two semilunar valves. Okay, coming off the right ventricle, it's going to be the pulmonary semilunar valve. So the blood goes through there, into the pulmonary trunk, right and left pulmonary arteries, because it's going away from the heart. Okay, coming off the left ventricle, we have the aortic semilunar valve. Okay, so oxygenated blood goes through the aortic semilunar valve into the aorta. So it tells you where it's going. It tells you where it's going. The tricuspid and bicuspid valve, okay, are side by side to each other. Okay, the pulmonary and aortic semilunar valves are front to back. Okay, so the pulmonary's in front, the aortic's in the back. Okay, let me show you a picture. Okay, okay. So right here, this is my right side of the heart. So tricuspid, bicuspid. So we took the atria off here. Two atria off. These are the ventricles. Okay, so on the right side, right, tricuspid, bicuspid, right, they're side by side. Okay, but coming off the right side here, right? You see the right side right here? It's going to be a pulmonary semilunar valve. On the left ventricle, aortic semilunar valve. So they're both back to back to each other like that. Okay? Okay. So now the valves are made up of chordae tendineae and papillary muscle. Chordae tendineae are very, very tough. Okay? If you grab one, we do the dissection and pull it, it won't break. The muscle will tear before that breaks. You can't cut it with a scalpel. Okay? The trabeculate coronae are those little folds. So when blood goes in, right, the heart opens up, it depolarizes, then it contracts. Okay? And here's a chordae tendineae right here. Right? So let's see. So here is the chordae tendineae. Okay, that's the papillary muscle. So when the valves are relaxed, okay, they're open. Okay, when they shut, they slam shut. The papillary muscle contracts and it pulls it shut. Okay, right. So right here, okay, so right here, blood would be in the two atria, even though we took them off. So the blood goes into the atria, right? Blood goes into the atria, right? Stretches, depolarizes those cells, and we get the muscle contraction. Then all the blood's going to leave the atria and go into the ventricles, and then those valves will slam shut, so there's no backflow, right? So all the blood will go in, it'll slam shut. Well, okay, so now all the blood's in the ventricles now, right? The blood will stretch those, the ventricles will depolarize, all the blood will leave the two semilunar valves, and those are shut. Dub. That's where you get that from. Lub, dub, lub, dub, lub, dub. Okay? And you can actually hear them slam shut, like that. Okay? I don't know where they get these dissections. These are so dried out. Does this look like an ugly baby? It's the two eyes, it's the nose, it's the mouth. It's like Quasimodo. You know who Quasimodo was? Character? The Hunchback of Notre Dame. Yeah, his name was Quasimodo. All right, no babies are ugly. I don't know, this one looks like it. This baby fell out of the ugly tree and hit every friggin' branch on the way down. It's a hard stop it. I'm not making fun of babies. Stop. The other class, oh my God, the other class is brutal. How you talk? I mean, dude, it's a heart. It's got dissected heart. It's not even a kid. Come on, relax. Calm down. All right. All right, so I like to keep everything real life. Okay, so stenosis is an narrowing. So sometimes you hear people have a mitral valve stenosis. That means that the door doesn't open up all the way. Okay, so you're not getting proper blood flow out of the heart. So you're not getting proper cardiac output. And we're going to go over cardiac output and stroke volume at the end. Okay, all right. If you have a prolapse, that would be a failure of the door to close all the way. Okay, so now you're going to get a backup of blood. Okay, back up into the atrium. Okay, so both are going to cause, because you're not getting proper output. What's the heart have to do? It has to make up for this. So the heart's going to work harder. Okay, it's like any other muscle. You're working, what's going to happen? It's going to grow. So you can get what they call left ventricular hypertrophy. Then this is what you don't want. A lot of times they go in, they can either fix with medication, or they'll go in through the ribs, and they could give you a new valve. Okay, most of the time they give you a pig valve, right? Not a lot of rejection because pigs are actually very close to humans. Okay, they don't have a hide like a dog or a cat. They actually have skin. So what we do is we learn to do stitches. We do it on pig's feet and stuff. It's quite sore. Okay, and you can do stitches on that. About 2 amino acids away from using a pig pancreas. Okay, so they can give you a pig valve, or they can give you a mechanical valve. Okay, mechanical valve. Okay, and within like a year or two, the heart will go back to normal. The heart will go back to normal. Okay. When you get to mechanical valve, though, if it's really, really quiet, you can hear it. It's like, click, click, click. Okay, so I had a student of mine. She's an older lady. She's a nurse now. And Felicia and her husband had the mechanical valve. And at night, when they were in bed, it was real quiet. She heard click, 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 right? And she couldn't sleep. She goes, what if I hear click, 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 click? And then nothing. That means the heart stopped. I go, it's not going to stop. I go, put the TV on or music or something, or a fan. You would hear. You'll get used to it. Okay. So my father never took care of himself, and he never ate right. So he was obese, and he had heart disease. He had type 2 diabetes. He had high blood pressure. So he had a lot of things. So he had to go get a new valve put in. Right? And he was the most horrible patient ever that you ever had. He'd go in there and have to staff him quick or take a vacation. He was not a good patient. So he goes in, and I walk in there, and I go, so what they give you? Did they give you the pig valve, or did they give you the mechanical one? He goes, they gave me a pig one. I go, isn't that ironic? I said, all your life you ate all that pork, and now they give you and they give you a pig valve, right? Right? He told me to go fornicate with myself, and he took me out of it. Yeah. So he got his he got like a foot of his intestines out one time. And so I went in, again, bad patient, and I tell you this, I had balloons and flowers. I walked in, you had balloons and flowers, I don't even effing balloons and flowers. And I'm like, okay, we'll try this tomorrow. I walked out, I went to the first nurse, and I go, get the balloons to pediatrics, get the flowers to geriatrics. I will see you tomorrow. You call constantly, oh my God, constantly. Yeah. When they were redoing Pascagoula Valley Hospital, they had they had the drawing of what it's gonna look like. And there was a car, I had a Sebring, and they just had a car sitting. I go, oh my God, that's my car at 3 o'clock in the morning in the circle. When they called me and said, you gotta get over here, if I was going bananas. Yeah, going crazy.
Not expensive or stents?
I'm gonna go down a little bit.
Oh, okay.
Yeah, I'm gonna do that a little bit. Okay, so keep the arteries from collapsing. I'm gonna show you that. Okay.
People say they have it.
Oh yeah, they're common. Yep. So rheumatic fever. Okay, this year you really don't see too much now because you have antibiotics. Okay, so you get scarlet fever, and that could go into rheumatic fever. Okay, but they catch it. Okay, they catch it. Actually, scarlet, yeah. You get strawberry tongue. Okay, you get a rash. In your throat we have Streptococcus pyogenes. So a cocci is around bacteria. If it's strep, okay, it's going to be in a chain. They have a staph that looks like grapes. Okay, so this is a genus, this is a species thing. The pyogenes. If I took a throat culture of everybody here, we're going to find some Streptococcus pyogenes. It's in your throat. It's when you begin to run down and you get sick, okay, and this overgrows. Now you have strep throat. Okay, that's not good. So So they give you an antibiotic and for 10 days and it clears it up. Okay? So anybody know who George Washington was? Anybody? Huh?
I think so.
They don't teach history in history class no more. I don't know how they're doing it now, but I don't know. All right, so he's the guy with the funny haircut on the dollar bill. George Washington hated that painting of himself, and he hated the artist that did it. Okay, because it really doesn't look like him. And this is what everybody knows it for. Okay, you can go online and look up what would George Washington really look like. And they show you. So he actually isn't that bad. So anyway, he was probably one of the best horse riders, equestrians in the country. Probably one of the best in the world. He had Arabian horses. He had a lot of money. Okay, he had a half brother that made money too. Just with stuff in the Caribbean and stuff, all like the sugar and stuff. He had a big plantation. He was like an inventor. He actually had a greenhouse with heat in it. Huh? The what? Oh, and stuff. So for the revolution, he actually paid for most of it out of his own money for his troops. He was really tall. He was about 6'3", 6'4", when the average male in those days was about 5'3". So he was like a foot taller than everybody else. Okay, he loved working on the farm, so he was big. He was tough. He cursed. He had a bad temper. He had incredibly bad teeth. He didn't have wooden teeth. He had a lot of money. When you would lose your teeth, they would save your teeth, or he would have ivory teeth, animal teeth. The only thing was, they would make it. It was a metal bracket they put the teeth in, and you had to hold it in your mouth, so you really couldn't chew with it. Okay, it was basically more for effect than anything else. He actually cheated on his taxes because he was going to the dentist so much, and he was kind of embarrassed, so he just put down he was giving the dentist gifts. He was giving gifts so nobody knows about his teeth. During the Revolutionary War, he lived on pickled tripe. Tripe is cow stomach, and his pickles is very, very mushy, so he could chew it. So anything the British threw at him, he could take because his teeth were so bad. Okay, so he's always in a lot of pain. But anyway, he went to Continental Congress, which in those days, the capital was Philadelphia. So he went to go ask for money for his troops. They had no clothes, they had no shoes, they had no food. He's like, you gotta feed these guys. He goes, they're fighting you. These are farmers, and they weren't giving him the money. So he went to talk, and they had this big banquet there for him with all this food, and he lost his shit. He flipped the table right over. He says, you give me money right friggin' now for these guys. And he walked out. People said, who was that? Well, that was General Washington. Cool, okay, we gotta get some money here. So he paid for that most of himself. When the war was over and he was leaving, he gave a speech. You can go look it up. There wasn't a dry eye in the place. He said, not only did I give all my money to my new country, I also gave my eyesight. His eyes went bad, and then he had to put on glasses to read the thing. So everybody gave him hugs and stuff, and then he left. They wanted to make him a king. He said, no. He goes, we just left England because it's the big king. I said, no, let's run it like a corporation. That's when the presidency came in. Okay? So he was riding one night. It was really cold and rainy and sleety out, and he got sick. He got a head cold. So it turned into strep throat. They didn't know anything about bacteria in those days. They knew nothing about the germ theory in those days. So the standard of care was that they would make you drink boiling water, scalding hot water, or boiling oil. And what it would do is it would burn your throat. Okay? So now he's having a hard time. He can't eat. Now he's having a hard time breathing, right? Well, what happened was when you burn it, you get blisters. Okay? So they thought that the fluid in the blisters was the poison that was making him sick. So what they did was they would take a probe and break the blisters. Okay? So now streptococcus now gets in his blood. Okay, now it became systemic. So now it's through his body. So what did you do in those days, the standard of care? Well, if you had poisoned blood, you got to get rid of the blood. So they would bleed you. So what they would do is, then you can look it up. There was basically razor blades with little spouts on them, and a medical book would tell you which arteries to go into to bleed you. And for so many different diseases, how many pints of blood you would take out. Well, he got weaker and weaker, and he went into shock, and he died. One doctor, he wanted to put him on ice and give him a transfusion of ghost blood to see if it would work. Of course, they didn't do it, but the guy had kind of like the right idea. He said, no, we have to give him blood. Don't take any more out. but they couldn't do human transfusions in those, nobody knew how to do it. And that's actually what he died of. Anybody know, who Washington Irving was? You know him, Tarrytown, across the river? Tarrytown, so there's an area, there, you look for he's a big author. He went to by the last name of Knickerbocker, at one time. So Washington Irving, has a house, right on the Hudson. If you can go see it, it's really, really nice. The whole area of Tarrytown, a lot of history there. So Washington Irving was named after George Washington. So after Washington was the president and he kind of retired, he was in New York City, he could walk around, nobody did anything in those days. So his nanny was a lady from England, her and her husband lived on the Irving estate. And he was a little kid. And so the lady goes, that's President Washington over there. And she goes, go say hi to him and tell him what your name is. So he goes over and he goes, hi, General Washington. My name is Washington Irving. I was named after you. So George Washington goes, yeah, good. And blew him off, but he patted him on the head. Washington Irving had this little bald spot. He said that was where Washington touched him. Kind of cool. The history's pretty cool. You know the legend of Sleepy Hollow? The Headless Horseman story? Washington Irving wrote that. Nobody teaches you guys anything these days. Just come to me. Oh, God. One of the best authors ever, and you don't learn about him? No, let's learn about Dracula the whole semester. My daughter took a writing class, the whole semester, one book. Who gives a shit? Who cares? Maybe she has a great author. I thought it was a good book, but please. They teach you guys all politics of today. I'm like, there was not that in those days, 150 years ago. No, stop putting it in now. All right, so there's 3 types of circulation. This is important, okay? The other shit was important too. Okay, so cardiac circulation. This is circulation that goes through the heart valves. This is the circulation that goes through the heart valves, okay? Okay, pulmonary circulation is the circulation that goes through the lungs when we want to get rid of the carbon dioxide and bring in more oxygen, okay? Systemic circulation is the circulation throughout your whole body, okay? So all the oxygenated blood is going to go to all the cells and all the organs, okay? As that's happening, all the deoxygenated blood, or all the CO2 in those cells that make up the tissues and the organs, is going to leave, okay, through the veins, okay? So, systemic circulation is going through your whole body. Okay, so your heart and your lungs are living tissues, so they are part of systemic circulation. Okay, they are part of systemic circulation. Okay? This is why we went over the George Washington thing, because it affects this whole body, all the organs. Okay? All right, so in our heart, okay, so the first organ to get systemic circulation, the first organ is the heart. Okay? It's the heart. So from the left ventricle, that oxygenated blood is going to go through the aortic semilunar valve into the ascending aorta. The first 2 arteries that come off there are going to be the right and left coronary arteries. They're going to bring oxygenated blood to the heart tissue. Okay? All major organs have a double blood supply, okay, or collateral circulation. We call that collateral circulation an anastomosis. Okay, we call that anastomosis. So if something happens, okay, you're still getting blood supply there. Okay, so we have a right and left coronary arteries that bring oxygenated blood to the heart tissue itself. Because remember, we need oxygenated blood to make ATP to make the heart beat, okay, to make it contract. Okay, I'm not going to test you on the branching off. Just know right and left coronary arteries bringing oxygenated blood to the heart. Okay, but we do have an anterior interventricular or left anterior descending branch that goes into both ventricles. The circumflex branch goes around the back, that goes to the left ventricle, left atrium. The right coronary goes to the posterior interventricular branch and supplies the 2 ventricles, and a marginal branch supplies the right ventricle. Okay? And this is what it looks like here. Here's the circumflex in the back. Okay? All right? Let's get to now to here. Okay? All right, so now we've got all oxygenated blood to the heart. Okay, so now when a heart beats, it's going to make up CO2, right? It's going to get that waste product. We got to get rid of that deoxygenated blood. Okay, so that's all going to wind up in here. So you got a small cardiac you got a great cardiac, you got an anterior cardiac. These are all gonna drain deoxygenated blood into the coronary sinus, and from the coronary sinus, that deoxygenated blood goes into the right atrium. So we got superior vena cava, inferior vena cava, coronary sinus, deoxygenated blood in the right atrium, goes through the tricuspid valve, into right ventricle, it gets pumped through the pulmonary similar valve, into the pulmonary trunk, right and left pulmonary arteries back to the lungs, okay? And we breathe out that CO2, okay? So the coronary sinus is gonna receive blood from the great cardiac vein, middle cardiac vein, small cardiac vein, and anterior cardiac vein. Okay, don't test you on these, just know the coronary sinus, they're all gonna eventually get in there. Okay, let's go back real quick. We're gonna go over this again next week. All right, so now, if you get a blockage in any of these blood vessels, okay? Okay, so we went over thrombosis, right? If you have a thrombosis, it breaks free and you get an emboli, okay? It's in the heart, it's cardiac embolism, okay? So wherever you get that blockage, okay, distal to the blockage, you're not gonna get any blood flow. Okay, that's gonna be called ischemia. The ischemia is going to cause decrease in oxygen to that area, correct? That's gonna be called hypoxia, okay, and that's gonna cause cell necrosis or death of the cells, okay? All right, let me skip to here. Okay, so a partial obstruction, okay, may cause ischemia. Okay, that's decrease in blood flow, which will cause hypoxia. That'll give you some chest pain. It's called angina pectoris. Okay, so if you have any pain high up in your chest, down the left arm, especially up into the neck, go to the hospital right away. Okay, go to the hospital right away. Okay, a complete obstruction, okay, will cause the distal tissue to start to die. That's called necrosis. That's called a myocardial infarction or a heart attack. Okay, or a heart attack. Okay. So right here, this is a normal artery. So this is called the lumen. Lumen's the hole that goes through, right? This is the lumen. Okay. So you can get proper blood flow, right, to where you need it. Like this. Okay. This here is an artery. Okay, that's obstructed with some plaquing. Okay, so atherosclerotic plaquing. Again, this could be fat. Okay, it could be some cellular debris. Okay. So now you're not going to get proper blood flow to that area. So you're not going to get proper oxygen to that area. The heart's going to have to work harder also. Okay? So this here, right, this is a happy artery. Happy, right? Not disease. Unhappy. Happy, unhappy. What do we want? Happy. What don't we want? Unhappy. Lay off the greasy food. And the smoking. And the smoking. Okay, let me skip down. We're gonna go over, next week we're gonna go over EKGs with you. Okay, so I'm gonna go in here. Okay. What am I doing? Okay, so if you have a blockage, okay, in any of these major arteries, okay, a lot of times they could clean it out, okay, or they can put a stent in. Okay, we'll go out in a second. Okay, if they can't and the blockage is too big, they'll bypass the blockage. So what they'll do is they'll take a vein out of your leg or one of your arms, because you have a lot of veins, and they'll graft it in. Okay, they'll graft it. So when someone has quadruple bypass surgery, your 4 major arteries going to your heart are blocked. That's a big deal. Okay, so they should give you a plaque if you make that happen, right? But right, so they have to graft it here. And sometimes it just might be a little clog, okay, and you might get some chest pain, shortness of breath, okay. So you go to the hospital and they'll check you, okay. And what they'll do is they'll do an angiogram. So they shoot a dye in you and they look at an X-ray, okay, and they'll look to see what a blockage is. So it'll look something like that, okay. That's an angiogram, okay. So now, if you have a blockage, okay, if you don't have a blockage, you go home. Okay, you go home. Okay, no blockage, we're cool. Okay, it might just be a panic attack or something. Okay. If you do have a blockage, what they'll do is to do an angioplasty. So what they'll do is they take this tube, they put a hole in your groin, right? They go through that artery. So they go through the femoral and iliacs, and they look on the X-ray, they take the tube, and it goes all the way all through your arteries until it gets to the part where it's all clogged. Okay, and there's a balloon at the end of it. And they blow the balloon up, and it squishes all the fat away. Okay, so now you get proper blood flow again. If they think that it's going to, if it's not going to hold or it's going to collapse, they'll put a stent in. Stent's about the size, you know, a click pen, a little spring in it, that's about what it looks like, okay? So it goes in with the stent, they drop it in, it goes through the catheter, and they drop it in. So if you get an angioplasty, you'll go home that day, okay? A nurse, when they sew you up, they just gotta lean on it for 20 minutes. They lean on the cut so you don't bleed out, okay? If you get a stent in, you go home the next day. You go home the next morning, okay? And that's what it would look like. And you keep those in your whole life. Keep that in your whole life. All right? All right, we're gonna stop here today, okay? And then we'll talk about EKGs next week, okay? All right. Okay, grab pens real quick. Pretty easy day today, we're ahead. Then next week, test, okay?